Logic 0, example 29.1, not using conditional proof. In this example, it's to start us off in this chapter on conditional proof. I'm going to do a proof that doesn't use conditional proof, but then I'll go back and I'll do it using conditional proof. So and we'll see the difference. So we have this as our problem. We're given A only if B as a premise, and we want to derive from that the statement both A and C only if B. Okay. So one way that we can approach this is that we could use implication. And in line 3, we can use addition. And I'm going to add not C. And notice that when we use the rule of addition, if you think about it a little bit, you can really just add or blah, 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 anything to any statement. That's really what it says. And that is a valid inference. And, sometimes students have a little bit of trouble swallowing that. Like it seems too good to be true. Like you can just manipulate things that way. But it is a valid inference. And in a circumstance like this, you kind of need to get creative about what you're adding on to make it all turn out right. But as long as you're following the rule, it's all kosher. It's all okay. Okay, and then here we can do associativity, so of disjunction. So I'm going to associate those together differently. All right, and we can use commutativity of disjunction. So commutativity of disjunction. And now we can use associativity again. So I'm going to associate together not A or not C and leave the or B part out there. This is 5 by associativity. And then we can do a little De Morgan. So De Morgan is just acting on this part. It's a rule of replacement. And so we can just take part of the statement in line 6 and apply the rule of De Morgan to that. And then finally, I think, let's see, we can do A and C only if B on line 7 using implication. And that's what we wanted to prove. And so there's our proof.